A very good morning, my dear students. Here in that continuation of this chapter, I'm here with this lecture number 8, chapter 7, Equilibrium. So let's start as usual with a quote. And the quote is that the expert in anything was once a beginner. And this is a very important line for everyone. The one who is expert in nowadays, sometime, somewhere, he or she was also a beginner. So once you will begin the things, then only you will be you will be considered as an expert in that, isn't it? Okay, so let's do that. Ionic product of water. Water is a weak electrolyte and undergoes self-dissociation to a small extent. I have what is this? Water is a weak electrolyte. That means it never dissociate in completely. It never dissociates. Yes, so it undergoes self dissociation to a small extent, and let's see how it is. So this is called autoprotolysis. Okay, like one H2O molecule. This is one H2O molecule. This is first H2O molecule and another H2O molecule. When they combine with each other, what happens? One will give H plus. So due to this will be left with the OH minus. Yes. So this is left with the OH minus. And this H plus is going to combine with this to form H3O plus. So these H2O is going to combine with each other and then it will form H3O plus. Got it? So since in this reaction the water molecules react with itself, so that's why it is called autoprotolysis. Autoprotolysis of water, we can say. Yes. Okay, why proteolysis? Because the one water molecule is leaving H plus and that H plus is gained by some other H2O molecule. So that's why it is called proteolysis, and since it is occurring between same, so that's why it will be autoproteolysis. Okay. Now, ionic product of water. So what is this ionic product? As the name suggests, product of ions. Okay. So when we do that, H2O plus H2O, what will happen? This will give you H3O plus and OH minus. Let me use another color. Okay. Then next is the dissociation constant for the ionization of water will be K is equal to, we know that dissociation constant, product concentration upon reactant concentration. So product concentration is H3O plus and OH minus. Reactant concentration is H2O into H2O, isn't it? So this is a constant and this is also a constant. So what will happen? The constant answer, since the degree of dissociation of water is very small, so the concentration of undissociated water may be practically taken as constant, and thus we have this. This is a constant, and this is also a constant. So I'm taking the constant on one side here. Okay, K into H2 concentration, and then it is left with this. So constant multiplied by constant will give you another constant. Okay, this is called Kw. Okay, and that Kw is called ionic product of water. So that I have written here, that Kw is a constant and that is known as ionic product of water. Its value is constant at a particular temperature. For a fixed temperature, its value is always remains constant, but it can change. It varies with the change in temperature. How it will be, I will show you in a table. Note, to be learned, that at 298 Kelvin, the value of Kw is 1.008 into 10 to the power minus 14, and approximately you can take it as a 1 into 10 to the power minus 14. That you can take it. Okay, so we can say that ionic product value Kw, that is equal to concentration of H3O plus multiplied by concentration of OH minus, and that will be equal to 1.008 into 10 to the minus 14 mole square per liter square. Okay, so in other words we can say like this. And since neutral, if I will talk about the neutral solution, this is neutral solution. So in that case, the concentration of H3O plus and the concentration of OH minus will be equal, isn't it? So can I replace this OH minus by H3O plus? And if I am replacing this OH minus here, so I can write like this H3O plus whole square, that will be equal to this. So concentration of H3O plus, if I want to take, I have to take the square root of this, and that will give you 1 into 10 to the power minus 7 mole per liter. And that is the reason for the neutral solution, whenever we talk about the neutral solution like the pure water, the concentration of H3O plus will be equal to O concentration of OH minus, and that will be equal to 10 to the power minus 7 mole per liter. Got it? So for a neutral solution, or you can say that for the pure water, the concentration of H3O plus and the concentration of OH minus ion will be equal, and that will be equal to 10 to the power minus 7 mole per liter. So here is a table. It's not like you are not required to learn this. No need to learn this. Just for reference, I have written it. Effect of temperature on Kw, how the temperature affects the Kw value, or you can say that how the Kw changes with the temperature. Yes, so at 273 Kelvin, you can see that this is a 0.113 into 10 to the power minus 14. At 283, it is 0.298 into 10 to the power minus 14. 295, it is 1 into 10 to the power minus 14, and 298, it is 1.08008. So that is the value. To be more precise, you have to say that it is 1.008, but for the calculation, you can take it 1. Yes, 323, this is the value, and 373, 7.50 into 10 to the power minus 14. That means the order of this value will always be in terms of 10 to the power minus 14. Only this value, these values, that will change. Got it? It is clear that the value of Kw increases with rising temperature. And we can see that as the temperature increases, the Kw value increases. And this can be easily understood by Lee-Chatelier principle. Let's see how it is. So effect of temperature on Kw. Like this equation, we know that 2H2O, I can write it. Instead of writing H2O plus and H2O, I can write 2H2O. So 2H2O is going to give you H3O plus and OH minus. Here the delta H, the enthalpy, that is plus 57.3 kilojoule. Got it? In accordance with this, plus means it is endothermic. Yes, plus shows that it is endothermic reaction. So in accordance with the Lee-Chatelier principle, increase in temperature for the endothermic reaction, we know that high temperature is more favorable. Yes. So if we will increase the temperature, the equilibrium will shift in the right direction, forward direction, and hence more and more product will be formed. So in accordance with the Lee-Chatelier principle, increase in temperature will shift the equilibrium in the forward direction, producing larger concentration of the product, that is H3O plus and OH minus ion. Hence, Kw increases with rising temperature. We can see that. So question can be asked that prove, like how can you prove that on increasing the temperature, the Kw value increases, or how you will justify this. So you are supposed to answer like this. Yes. Next is hydrogen and hydroxyl ion concentration in aqueous solution of acids and bases. कैसे चेंज होते हैं, क्या concentration होता है, how we will find the pH, what is the H plus concentration, what is the OH minus concentration, that we are going to learn. Changing H3O plus and OH minus ion concentration on addition of acid. If we will increase the acid, some amount of acid in this neutral solution in the pure water, how the H3O plus ion concentration or the OH minus ion concentration will change. Yes, that we are going to understand. If we add a few drops of acid to water, the concentration of H3O plus ion becomes large, more than 10 to the minus 7. How come? Suppose that like this H2O is already 10 to the power minus 7. Yes. And if I am adding some H plus ion, so obviously iska kuch concentration hoga, so this is going to be increased, isn't it? So that's why it is said that the concentration of H3 ions becomes large, and that is more than 10 to the minus 7 mole per liter. Consequently, the dissociation equilibrium of the water shifts in the reverse direction. ये increase हो जाता है H plus ion product side में, and that's why equilibrium will shift in the backward direction. that is H3O plus ion would be combined with OH minus ion to form undissociated water molecule. That means ये जो reaction था 2H2O change into H3O plus and OH minus. So what will happen since this reaction will move in the forward direction, so they will combine and will give you this back. Okay. Water molecule, so that the value of Kw in the solution may remain the same as that in the water. So the concentration of OH minus ions may be calculated as how we will calculate. So this is the, like, we know that Kw is equal to H plus H3O plus concentration multiplied by OH minus concentration. So we can write like this. Yes. Thus the concentration of H3O plus ion will be more than concentration of OH minus ions in acidic solution. If it is acidic solution, then H3O plus ion in H plus ion concentration will be more than OH minus ion concentration. Got it? Okay, change in H3O plus and OH minus ion concentration on addition of base. Now I'm going to add base. If we add a few drops of acid to water, the concentration of OH minus ions become large. Now in this case, this is 2H2. Let me write again 2H2 and here H3O plus and OH minus. If I'm going to add OH minus ion more, so what will happen? This OH minus ion concentration increases. Yes. And due to which the equilibrium will again shift in the backward direction. They will combine. But the concentration of hydrogen ion decreases. See, if it will increase, so obviously this will be considered as decreased, isn't it? The concentration of H3 ions may be calculated as like this. The same formula we will use. So here, this is going to be increased. अगर ये increase हो रहा है, to keep this constant, be careful about this is going to be increased. So this value is constant. Yes. So to keep this value constant, this value will decrease, isn't it? Yes or no? So H plus ion concentration increases, and that's why OH minus concentration, we can say that will be more. OH minus ion will be more than H3. Here too we can say that H plus concentration will be less than OH minus ion. Clear? Yes. Now in acidic medium, this we have done in class 10th. Yes. In acidic medium, H3O plus is greater than OH minus, while in basic medium, H3 plus is less than OH minus, and in the neutral, both are equal. Yes. Expressing hydrogen ion concentration, and that is called pH scale. This pH scale gives that what is the concentration of that acid and base. It explains about that, and that was given by Sorensen. He was a scientist. He has given this pH scale, and about the pH he has given the description. Yes. So what is this pH scale? The concentration of hydrogen ion gives an idea about the acidic and the basic nature of the aqueous solution. Sorensen in 1909 suggested a new term for expressing the concentration of hydrogen ion known as pH or pH scale. First of all, you should know that what is this pH? pH is potential. This is called potential of hydrogen ion, or you can say that hydrogenium ion, or this is called potential, or this is also called concentration. Okay. The pH of a solution is defined as the negative logarithm of H3O plus ion concentration in moles per liter. This is the definition. If anybody asks that, well, how can you define the pH? This is the definition. The pH of a solution is defined as the negative logarithm of the H3O plus ion concentration in moles per liter. Mathematically, it is expressed as pH is equal to minus log H3O plus. This is the formula to be used to be learned. Yes. In the neutral solution, H3O plus ion concentration will be equal to OH minus concentration, and that will be equal to 10 to the power minus 7 mole per liter. So pH will be this 10 to the power, pH is equal to minus log H3O plus is equal to minus log 1 into 0, 10 to the minus 7 and 7. How it is, you know now how to find the log. So this is quite clear. Yes. We can say that this is log m, this can be considered as m, and this can be considered as n. So we can write like log m plus log n. So log n is minus 7. Now this value is 0. Log 1 is 0. And it is, we can term it as m power n. Yes. So log m power n will be considered as n log m. Yani ki this is minus 7 log 1. So again log 1 jo hoga, that will be what? Oh, sorry, this is 10 to 7, na? So log 10. So log 10 will be 1. So this will be minus 7 into 1 is equal to minus 7. And this minus 7 over here, and here it is 12 there, na? Minus here pe bhi tha. So this will be considered as the plus 7, will be equal to plus 7. So yeah. So if the concentration in the neutral solution, the concentration of H3O plus ion will be equal to concentration of OH minus ion, and the pH will be H7. Yes. Similarly, if we talk about the acidic solution, pH will be pH will be greater than 7. Let me use another color. For the acidic solution, pH will be greater than 7. For basic solution, pH will be less than 7. For neutral solution, pH will be equal to 7. Yes? Okay, now again the note that is some important point. So it may be noted that the pH is defined as the negative logarithm to the base 10 of the activity of hydrogen ion, and that is AH+. Activity of H plus ion, or you can say potential of hydrogen ion, or you can say potential of hydrogen ion, hydronium ion. Yes. At low temperature, the activity of hydrogen ion is numerically equal to its molarity. This is the point to be learned. Low temperature पे जो pH of hydrogen होता है, the activity of hydrogen ion, that is numerically equal to its molarity. जितनी इसकी molarity होगी उतनी ही उसकी pH होगी, and that is represented as H plus concentration. Hence, a scale has been introduced to express the acidic and basic character of a solution in terms of pH value, and that is known as pH scale. So let's see that pH scale, how it looks like in the next slide. This is a pH scale. It starts from pH 0 to pH 14. Okay. pH 7 is the neutral one. This is neutral one. If we go below 7, it will be acidic solution. This will be acidic solution. And if we go like above 7, it will be basic. So pH 14, that means most basic. This is most basic. And pH 0 or 1, this means most acidic. Yes, clear? So this is another way, like some examples. Battery acid, H2SO4, conc H2SO4 we use. So that has pH 0. Stomach acid 1 or 2 के बीच में होता है. Vinegar 2, orange juice 3, tomato 4, black coffee 5, urine 6, water 7, seawater 8. You can say baking soda 9 pH. Indigestion tablet like Union Zyme or all that has pH 10, ammonia solution 11, soap is water, that is 12, and bleach 13, and last drain cleaner जो होता है उसके वो most basic होता है, that is 14. So this is an example. Indicator है भी है और pH color, how it will look like. Yes, in the pH chart it will match how it will look like. So color भी दिया हुआ है यहाँ पे. Now pH and pOH. Like pH, it is also possible to define pOH. Like pH was kya? Potential of hydrogen ion. So pOH, we can say that potential of hydroxyl ion. Yes. So instead of H plus, we will use just OH minus. And that's so simple. So pOH is equal to 10 to minus log concentration of OH minus ion. But we know that H3O plus and OH minus is equal to Kw. And if I will take log on both sides, it will be log this into log Kw, isn't it? So this is log m into n. So let me just separate it. Log m plus log n is equal to log Kw. Now, this H3O plus can be considered as minus pH, isn't it? In the last slide we have done. pH is equal to minus log H plus or H3O plus, we can say. So if I'm taking log H3O plus, so it will be minus pH, isn't it? Similarly, minus pOH is equal to minus pKW. Similarly, we can say. So take the common, minus common, and it will be pH plus pOH is equal to pKW. Clear? So like if it was H plus concentration was 10 to the power minus 7, so we have seen that how pH will come 7, isn't it? Similarly, if Kw is equal to 10 to the power minus 14, so pKw will be what? 14, isn't it? So this is at 298, pKw is equal to 14. Clear? And pH plus pOH will be 14, we can say like this. Okay, so note, it may be noted that the solution having pH between 0 to 2 are strongly acidic. Those with pH between 2 and 4 are moderately acid, while those having pH 7 to 10 are weakly basic, and those having pH 10 to 12 are moderately basic, whereas the others which we have pH range 12 to 14 are strongly basic. This is the point to be noted, and you people are doing since class 10th, so I hope there will be no problem in this. Measurement of pH is commonly done by pH paper, but for precise measurement, the pH meter is used. Okay. So here is a question. Let's solve it. Okay. Calculate the pH of a sample of soft drink whose hydronium ion concentration is 3 into 10 to the power minus 8. So we know that pH is equal to minus log H plus or H3O plus, isn't it? So minus log, and this concentration is given this 3.8 into 10 to the power minus 3. So can I consider this as a M and this is N? Sorry, N. So this will be equal to minus log, let me 3.8 plus log 10 to the power minus 3. Can I write? Or minus log 3.8 value is given here, 0.589. So let me write 0.589. This is point, yes, plus, and this is log m power n. So can I write n log m, isn't it? So this will be minus 0.589, and this is plus minus 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 plus. So 3 log 10 is equal to 1. So just subtract it and you'll get it. 1, 1, and then it will be 94.2. So this is the pH. And doubt? Okay. So here's another question. pH of a tomato juice is 4.4. Calculate H3O plus and OH minus anti-log the other. So do it in the same way. We know that pH is equal to minus log H3O plus. So we want this log H3O plus concentration H3O. Yes. So what we'll do? This is anti-log. Taking anti-log both side. Taking anti-log both side. What we will do? This is minus, anti-log pH is equal to, anti-log link, so this will be cancelled out, isn't it? And it will be minus H3O plus. So what will happen? Anti-log pH is given kitna? This is 4.4. So anti-log 4.4 is equal to minus H3O plus, and we want H3O plus. So what can we do? We can just minus यहाँ से हटा के, or we can put it on this side. Yes, here. So minus anti-log 4.4. This is the value here given, isn't it? So just write down. So H3O plus is equal to 3.98 into 10 to the power minus 4 mole per liter. And if H3 plus concentration, OH minus you can find, because this is 10 to the power minus 14, isn't it? So if I'm writing this 14, so you want OH minus, so what I will do, 10 to the power minus 14 upon this H3, and 3.98 into 10 to the power minus 5. So just solve it, 1 upon 3.98 it will be, and here it will be 5, 10 to the power minus 9. Solve it and you'll get this answer. Any problem? I hope it is clear. Yes? Now next, move to next question. The value of Kw is given at a certain temperature. Calculate the pH of water at this temperature. So Kw is given, that is 9.55 into 10 to the power minus 14, and you are supposed to like pH kya hai? Okay, pH of the water at this. So how can we do this? We know that H plus concentration and OH minus concentration is equal to Kw, isn't it? Yes. So Kw is given. If you will find the H plus and concentration, then you can find pH, isn't it? Okay, and for water, it is given as a water. Yes. So for water, we know that for water, the concentration of H plus is equal to concentration of OH minus, isn't it? Okay, so we know that this is equal. So can I write like this? H plus square is equal to Kw. So just find the H plus, and that will be root under Kw. So Kw is 9.55 into 10 to the power minus 14. The square root of this 10 to the minus 14 will be simple, 10 to the power minus 7, and if you take the square root of this 9.55, you will get 3.09. Okay, so you got the H plus sign over here. So find the pH. pH is equal to kya hota? Minus log H plus. This is minus log and H plus. Instead of this, you can write 3.09 into 10 to the power minus 7. Now again, this is minus log 3.09, and can I write like this? Minus 7 log 10. So this will be 1. So here it is minus, and 3.09 value is 0.49 given, 0.49. And this is minus plus 7. So just calculate it. It will be somewhat little less than 7, isn't it? That means this is the answer, 6.51. Clear? I hope it is clear. Okay, let's move to next. And this is the question which I'm giving you as a homework. You have to do it. If there is any problem in this log and anti-log, you just watch that video, log and anti-log, how to find this. Any confusion in this finding log and anti-log, link is in description and pinned comment mein. So just go through with that video and understand that how this log and anti-log can be calculated, and then solve this question. Okay, so that's it for today class. I hope you, whatever I have explained, you got it. So next is acid-base equilibrium and ionization of acid and bases. Lots of numerical will be there, so just be attentive, be sincere, and whatever the back thing we have explained, I have explained, just go through with that properly, and if there is any doubt, make it clear before that. Okay, so okay class, thank you. We'll meet you in the next video.